This video continues the idea of factoring. And so before, we had talked about factoring out a monomial. We look for the greatest common factor of each term, and then we use that and we divide out each of the original terms by that factor, and then we have something left over. And now we've factored something out. We have two factors that would create that initial polynomial. But in this particular problem, we don't have a common anything. And so the question is, well, how do we do this? Well, you actually factor twice. And I'll show you how to do that. You can, by the associative property, gather up any two factors you want. My rule is, and it seems to work better this way, make sure you write your polynomial down, and you write it down in terms of in descending powers of the variable. So you'll notice I have a 3, a 2, a 1, and a 0. Okay, so now it's in descending order. Now the first thing I look for is the greatest common factor. Well, my coefficients are 1, 2, 3, and 6. They don't share any common factors. And I don't have x's in all of them. So I can't pull anything out that's in common. So at this point, what I'm going to try to do, and it's an attempt. This doesn't always work. But what I'm going to try to do is I'm going to take and I'm going to gather up my first pair of terms here. Then I'm going to gather up the second pair of terms to include the sign. And I haven't really done a very good job here. Let's go ahead and move that sign a little closer. Okay, so I'm going to gather up my pairs. Now this works really well when you're talking about quadratics, which are degree 2 trinomials, and then cubics, which are degree 3 polynomials. And so what you do is you gather up each set or each pair, and then you put a plus in between. Always gather up the sign on that third term. Always. And then put a plus sign in between. Okay, now we're going to factor each pair separately of one another. If we do this and it's factorable, then we're going to get something that looks very similar to the distributive property. If we factor out the greatest common factor of 1 and 2 on the first pair, we come up with 1. But we also have at least 2 x's in each, and so we can pull out an x squared. And now if we had 1 divided by 1 is 1, we had 3 x's, we took 2 away to leave 1. On the second term of that first pairing, you have 2 divided by 1 is 2. We had 2 x's in there, we took 2 out, and so there's none left. And so there's our first factor set. Bring down the plus sign. Now, if there was a negative sign in the front of either of these, I would have pulled that out. Okay, always pull out the negative. But in this case, I just left it fairly simple. I said, okay, well, let's go ahead and keep this somewhat easy. And I'm going to keep all of them positive. And so I can bring out a positive 3 from there. And I can also bring out a positive 3 from there. So I can go ahead and bring out a plus 3 from both. 3 divided by 3. You'll notice there's no x's in common with both, and so I can't bring out any x's. So 3 divided by 3 is 1 x. Plus 6, so positive 6 divided by positive 3 is a positive 2. All right, now we're done. Or at least it seems that way. We want to take a very, very hard look at what our distributive property says. And normally you see it as A times B plus C is equal to B plus, or AB plus AC. Another way you can write this is that B plus C times A is equal to BA plus CA. One is the left hand and one is the right hand distributive property. Okay, sometimes you have numbers that you must do this in this order because the order of multiplication cannot be reversed. We're not really going to go into that here, but it serves its purpose in this case. Notice that if I have a common factor on the right-hand side of my two terms, and they're the same, then I can factor them out. Well, I have 1x plus 2 here, and I have 1x plus 2 here, so I can go ahead and factor that out. And then when I do, whatever's left is what goes in the other parentheses. And so I have an x squared here, I have a plus 3, that's what's left. So I have x squared plus 3. And that's how this factors. So I was able to factor a cubic equation or expression using something called grouping. So if you look in a book, very often they are going to refer to this as factoring by grouping. It's just a technique to make it a little bit easier to check to see if the distributive property can be used. Now, these two factors must be the same. If they are not identical, it doesn't work and you can't factor it. If you do everything right and you end up with two different factors here, that's called prime. You can't factor it with the techniques that we currently have. We meaning right this moment. Not that it can't be factored at all, but that we don't know how right yet. Okay, we'll talk about more factoring tips later. Okay, I'm going to do one more example here. Okay, and I'm going to go ahead and continue on with this this factoring by grouping. And I've got another example prepped. And so we're going to use the same technique that we used before in order to run this example. Again, now, remember, when I started, I said, okay, first of all, do I have everything written in descending order of powers on the variable? And here my variable is x. I have 3, 2, 1, 0. They are in descending order. And the next thing I mentioned is go ahead and factor out the greatest common factor if you can. You'll notice that each one of these numbers is divisible by 3. I can factor out a 3 then, and so I'm going to go ahead and do that. And so using our technique from the previous video, I have 3 divided by 3 is 1, and so I just have x cubed. I have negative 6 divided by 3 is negative 2, x squared. Negative 9 divided by 3 is a negative 3, x. Positive 18 divided by 3 is a positive 6. The other 6, the kind without the 1 in front of it. All right, now at this point you might think, okay, I'm done. I don't have to do it. But remember, I warned you in the previous example, when you factor something out, you might be able to factor one of the factors. In this case, let's try to factor this. And now I'm going to forget about the 3 for a second because it's going to mess me up if I keep it in there. Although, when I get done with my answer, my 3 has to go back in. Okay, so now kind of off on the side, just to make sure I don't confuse it with the answer, I have x cubed minus 2x squared minus 3x plus 6. And now according to grouping, I'm going to take that and I'm going to gather it up in pairs with the signs. And then I put a plus sign in between the two factor pairs, or the two term pairs. Now I factor each one separately. So each pair gets factored separately. There's a 1 in common with both 1 and negative 2, so that becomes 1. I have 2 x's at least, and so I can pull out 2 x's. When I do that, I had 3 x's, or 1 divided by 1 is 1. I had 3 x's, I took 2 away, there's only 1 left. On the other term, I had negative 2 divided by 1 is negative 2. I had 2 x's, I took 2 out, there's none left. I'm done with that one. Plus. Now notice that I have a negative out front immediately. Without even thinking, I'm going to bring out a negative. I don't want negatives in there. And so when I do this, then I want to take out, well, 3 and 6 have a common factor of 3, so I can bring out a negative 3. There are no x's in common with both, and so I don't have to worry about that. So negative 3 divided by negative 3 is 1. The x doesn't go anywhere. Positive 6 divided by a negative 3 is a negative 2. And I'm done. Now notice that I've got a common factor in both. And so I can break that off. That's one of my factors. The other factor is what's left. And so the other factor is x squared minus 3, or plus a negative 3. Either way, it doesn't matter. Okay, so now I've got those factors, but don't forget, I had a 3 up here as well. So I have to bring that 3 back down. So it's really 3 times x squared minus 3 times x minus 2. And that is fully factored out. This one we will we'll discuss in a different video, but that one could actually be factored again. We'll talk about that later.